Hi friends, welcome to my channel. So in this video we will solve this problem, which is longest palindrome in a string. I will give I'll talk about the question a bit, and then we will run one simple test case on the string on the example, and say at the same time we will go through the program as well. So my approach which I am trying here is along with the test which we are going to run on the any problem, maybe like for in this we have the string problem. What we will do, we will learn the code as well. We'll understand how the code works, how each step works, so that the main thing is sometimes we understand okay how our solution will work, right? This is how the algorithm should be. At the time of writing code we miss something or we don't understand each and every step. So that will what we will do here. Okay, so let's get started. Maybe I will just give a high level overview of the problem. So the problem is we have been provided a string. Let's say this is a string which is given to us, and then we have to find out the longest palindrome in this string. Palindrome is basically like if you reverse the string, then it should be equal to your, let's say if this is the input string, then if you reverse this, both are not equal, but this is provided and then you reverse it, so this is a palindrome. So this is what a palindrome is. Okay, so this is what about the problem, and I have already written the code here. The reason being, like, I don't want to spend much time writing it here. I will talk about the solution and code at the same time, so that it helps you understand okay what each step here means, and how we can solve the problem efficiently. So just I will tell you that for solving this problem, one approach which is very basic brute force approach is considering all possible strings from B, like let's say B, then BA, then BAB, then checking whether it's a palindrome or not, then again moving to index another, starting from A, AB, ABA, whether this is a palindrome or not. Okay, so that is a brute force approach, but here what we will discuss is a bit optimized approach, which will be your of n square time complexity and with no extra space. Okay, so no extra space, you can say it's O of 1, right? So this is a bit different from the dynamic. We also have approach, dynamic programming approach, DP, for solving this, but here we will talk about solution in O of n square time and no extra space. So without going further ado, let's deep dive into the solution here. Okay, so I will talk a bit about the solution, how it works. So basically the solution works in such a way that instead of just checking all the strings whether those are palindromes or not, we consider each index. Let's say this is your string, then considering index B, which is your 0, we try to see with if you keep B as your center of the string, then what is the maximum length of string possible that it's a palindrome. Okay, so what I want to say is, right, let's say you consider is index B. Now you see, go one step ahead, you go one step back. If there is a character here, there is a character here, so B itself is a palindrome, right, of one length. Now you see, okay, if I go ahead and I go back, whether this forms a palindrome or not. If it forms, you go ahead, and if it does not, you don't do anything, you just move to your next index, like which in this case will be A kind of. Okay, so maybe let's run an example and side by side let's keep on looking in the code how it goes. Base cases I have not mentioned here. The reason, like, you have to check whether the string is null or not. If the string length is 0, then you have return 0. If it's 1, then it's a one length palindrome, you can return it. Okay, now moving on to our next step, you have initialized some variables start and end to measure to return the length of the string. Then you are executing this for loop, as we said, right? We will check each index and try to see if you keep this index as the center, then what's the maximum length of the palindrome string possible for that being a center. Okay, now this is the for loop. Now you go ahead, and this is the expand function. So what this expand function does, right? So this is the main function, I would say, the which looks for the logic, okay, whether if you go one step back and one step ahead in the string, whether you get something or not, right? So expand function, which is written here, this one, let's talk about that. What it does the same thing, right? You send the string, you send the character. We'll talk about this step as well in a while. And then this start and end, you're talking about this only, right? This you have considered as center, you're passing it, you come here in this expand function. Now what we just talked about, right? Let's say again consider it, b is your index, you are putting I, which is 0, again I 0. Now you came to this function. What this function is trying to do, it's checking whether this character is same or not. At index 0 you have b is equals to b, okay, you go inside the for loop. What it does, L minus minus R plus plus. Currently you sent both as 0, so it will be -1 and +1, okay. Now it again goes to the while loop. Now -1, here again you have to check for the base cases. Base cases are whether left and right are valid values or not, right? Because if it should not be beyond the length of the string, or it should not be negative. So your for loop will break, while loop will break. Now what you have to return. Now we'll talk about this, why we are using R minus L minus 1. So you know, right? R is your last index, L is your starting index, and this is the string. So R minus L makes sense. Why -1? -1 reason being, when you are doing this operation, right? When you just L minus 1 is R plus 1, this is after performing this comparison, right? So when you were at 0 0, so if you do 0 minus 0, you got nothing, right? But when this operation was performed, now the values are -1 and 1, so it will be 1 minus -1 minus 1, so it will be 1 plus 1 minus 1, which is 2 minus 1 1, right? So if you go here only, right, because of these two operations, your length got increased by 2 instead of 1, right? Because you compared two characters, but one was already involved, the difference already included 1. So that's why R minus L minus 1, that's why you're performing this extra -1 here, because after the comparison you're performing these steps, and because of these steps your one extra character is getting added to the length which you're returning here in this, okay. So this is for the expand function. We talked like how we are sending this left and right indexes, we are comparing, and then we are then after comparison, obviously we are, as we discussed, we are one step back, one step forward, we are moving. So we are doing L minus minus and R plus plus. And at the time of returning the length, because of this operation, so these, after checking for these character, we got changed twice, like we increased twice. So that's why we are doing -1 to make sure, okay, we don't increase it 2 times the length. Now there is this logic which is the reason why the complexity, this is a more efficient approach. We're expanding 2 times. Instead of checking one as the character, one index, we are checking for 2 indexes and trying to expand across those. Why? The reason is we can have a palindrome of odd length and even length, right? So when it's an odd length, so your character which is in the center is it gets compared with itself only. That's why you said I comma I. But when you have an even length palindrome, at that time this character gets compared with this character, not with itself, right? So in case of odd length strings, the first one works. In case of even length strings, it gets compared with the next character. So it's A B B A. So if you're checking for B, you have to check it with its next character. That's why while checking for the expand function, we are doing I comma I plus 1. So it gets checked with this. Then let's say if you're running for this string and we call this function 0 1 2 3, I is 1, I plus 1 is 2. So in this function you get 1 and 2. Then you check 1 and 2 is equal, yes. Then you do L minus minus, which is 0, R plus plus, which is your 3. Then you check again, these are equal, yes, those are. Then you again perform, which is -1, and this is your 4. But again you will check your base case, and this is not possible, then you will exit from the loop. When you exit, you do 4 minus -1, which is your 5, -1 is your 4. So the length which you return is 4, which comes here. So that's the reason why you expand there. Okay, now as we just saw, right, there's a possibility you have odd length or even length string, palindrome string. So that's why you get two length out of these. So, okay, so this length is actually the maximum of length 1 comma length 2. Sorry, yeah, actually this length which you have here is maximum of these two. So this goes, yeah. So that wasn't bad. So you have to just figure out like which is max of these two. Then after getting this, you have received your length from here. What is the length of your string, right? Now the start and end initially were 0 and 0. So the first time it will always be, your length will be greater, like, right, it's if it's a 2 length string, then always like you will get 1, right, because of doing this operation, odd length 1. Now you have to figure out the starting and ending points, right? Till now you just figure out the length. Now you want to return the string. The question tells you to return not only the length of the string but the string itself. Okay, so now you know, right, the index, you got the length because of the index you were working on. Now you need the starting point which will be behind it and the ending which will be after, right? So you will do something minus operation, here you will do plus operation, right? Start I minus end I plus. Now you already have the length, so you know it will be length by 2 both of the side. Now the reason we have length minus 1 by 2 for the start, why? So now we will go again back to a logic of odd and even length strings. For odd, for even, so you know, right, if you see this one, this is I and this is I. So in this case you do I plus length by 2, you will come here. So let's say I was 1 and the length was 3, right? So 3 by 2 is 1. So 1 plus 1 is 2 and 3 minus 1 is 2. I minus 1, which is 0. So your length string start and end index is 0 to 2, right? So here what's the logic is, if it's an even length string, right, then in that case I is something which is already included. If it's odd length string, you're good, right? You add length by 2 and here it gets minus 1 by 2. So you're good, like this index is getting added at both of the places, right and left, both places, right? But if this is an even length string, right, in that case this index I is already included here. So if your length is 4, 4 by 2 is 2. So for the end you have index 1 plus 2, which is 3, which is fine. But in this case, in the left, you have 4. If you have not done this 4 minus 1, what would have happened? You would have done 1 minus 2, which is minus 1, which is wrong, right? So in this case you do 4 minus 1 by 2, which is 1, right? Then 1 minus 1 is 0. So your lengths are 0, 3, which is 4. So the only point we are discussing this is, in the case when we have even length strings, this index is already included in the half left of the string. This AB, if you reverse it or you check the palindrome from here, B equals to B, A equals to A. So this is already included. That's why in the start you always do minus 1 for even. If it's odd, doesn't matter, right? If it's 3, then 3 by 2 or 3 minus 1 by 2, it will be 1 eventually. That doesn't matter. But in case of even, we need this minus 1 here. Okay, so this is how you calculate your start and end indexes. And after that, once you get that, you just have to return the string. So in Java you have this function substring, which if you put the first and start indexes, start end plus 1 again, because substring function does not consider the last index. So if you enter 0, 4, it will return you 0 to 3, these characters only. It will not return you the 4th character. So that's why it's here. So that's pretty much it for this question. So we have to return the longest palindrome string possible, and this is the solution, where you try to take each character and expand across that, considering it as a center. and in O of n square time you get the result. Yeah, I think we should discuss about this space complexity and time complexity as well. So you see, we are not considering any extra space here. We are calling functions, that's a different thing, that whatever space is getting consumed there. And the time complexity, we are using one for loop here, n, and after that we are calling these expand function, and expand maximum it will call each character in the string once, not more than that. So in worst case scenario, you will always have O of n square and O of 1 space complexity. Okay, so I hope this approach helps you, and the explanation was helpful. Please let me know in the comments if you think there are any problems or with the solution or with the approach. I will be happy to look into that and discuss. Thank you.